Hello, marvelous Algebra 1 students, and welcome back to another day of solving inequalities. Today says advanced solving inequalities, but really we're just filling in the holes from the last video. You actually are going to know how to do pretty much everything on here, but there's some good practice problems that I've picked out for you, especially some ones that I find throw students off. We'll finish with a couple word problems, and that's about it. It's a pretty mellow class today, so let's see what we can do. It's a nice little opener here, nothing you haven't seen before. Remember, if this is the first time you're seeing this, though it shouldn't be, you can treat these inequality signs just like equal signs. And whatever you do to the left side, you have to do to the right. The only weird part is if you multiply or divide by a negative, you have to flip the direction of the inequality sign. And then at the end, we want to go through and actually graph our solutions. So go ahead and pause my soothing voice at this point to try these three problems, and then unpause and we'll see how you did. Ready, set, go. All right, welcome back, and let's see what we've done. We need to distribute the negative 2 here. That will give us negative 2x. A negative times a negative is a positive. 2 times 1 is 2, and this is greater than 13. From here, there are two values attached to x. Negative 2 is multiplying, and this 2 is adding. We know we undo addition and subtraction first. Same thing we've been doing the last 7 or so classes. Leaves me with negative 2 times x is greater than 11. And last but not least, we should probably go through and divide off the negative 2 that's right here. Anything divided by itself makes a positive 1. Up, we are dividing by a negative here, so we do need to flip the direction of the inequality sign. Does 2 go nicely into 11? Well, no, I don't think it does. So we can actually keep this as 11 halves. A positive divided by a negative is a negative. You can leave the negative on the 2 like this. However, you can also put it in the middle of the fraction, or if it makes you happy, you can put it on the top. I think it's commonly put in the middle if the answer is a negative, so I'll do that. Then we need to graph our solution, and it may actually help you to find the decimal equivalent. Remember, we read from top to bottom 11 divided by 2. I'll put a negative in here, which will be negative 5.5. Okay, so it might make sense to go by 0.5s here. I'll put on my negative 5.5. The negatives are to the left. We get more positive here, so this is negative 5, negative 4.5, and negative 4. Okay, and the other way, we have negative 6, negative 6.5, and negative 7. All right, we know we're starting at negative 5.5, and then it says x's have to be less than negative 5.5. Less than means more negative, so we go to the left. Excellent. And then last but not least, do we fill in the circle? Well, we do not, because there's no equal sign up here. Moving on. 5 is greater than or equal to 2 minus the quantity x minus 1. We've seen this situation before. We know we don't distribute the 2 to parentheses because 2 is attached by subtraction. We need to distribute the number that's multiplying, and there is an invisible 1 here. So I'm going to take this negative 1 and distribute to both. This will give me 5 is greater than or equal to 2 minus 1x. Negative times a negative is a positive. 1 times 1 is 1. We now need to combine like terms. When we do that, I see a positive 2 and a positive 1, which gives us 3 minus 1x. Again, I always like to rewrite this. I might run out of room here, but I'll do what I can. I like to put the x's first. So negative 1 times x, and then this is a positive 3. I find students do better this way because now they can see that we need to undo adding 3. Sometimes they think this means negative 3 up here. We'll undo adding 3 to each side. This leaves us with 2 is greater than or equal to negative 1 times x. Because the negative 1 is multiplying, we should probably undo that on each side. And that's going to leave us, let's see, a positive divided by a negative is a negative. We divided by a negative, so we need to flip the direction of the sign, and then we have x. Now, we discussed last time that I prefer to write the x's on the left side of the inequality. This says negative 2 is less than or equal to anything x can be. This might make more sense to you if you write it the other way, x and negative 2. The mouth is facing the x, so it needs to keep facing the x. This says x is greater than or equal to negative 2. So let's center at negative 2. Positives and negatives, negative 1, 0, and 1, negative 3, negative 4, negative 5. We are starting at negative 2. We need to be greater, which is more positive than -2. And because we can be equal to -2, we need to fill in that circle. Last one, hideous fractions, oh no. But remember, fractions are just a fancy way to perform division, and I bet if I asked you to take 1/2 of 4, you could tell me that's 2, and half of 10, you could tell me that's 5. In fact, the fraction 1/2 multiplying is really just a fancy way to say divide everything by 2. So knowing that, when we distribute the 1/3, a third of a number just means divide by 3. Don't forget it's a -1/3 though, so when I do 3 divided by 3, I do get 1, but a negative times a positive gives me -1, and of course the x tags along. A third of 9 means 9 divided by 3, that's 3, and negative times a negative is a positive. Less than or equal to 1. We combine like terms. I see 2 x's that will combine with 1x, which will just leave me with 1x. And then I also see a friendly -5 plus 3, which will give us -2. And that is less than or equal to 1. From here, I see that we can add 2 to each side, like so. And I'm going to do 2 things in this step. First, I am going to do 1 plus 2, which is 3. But also, this says 1x, but we should be comfortable now knowing that if there's a 1 in front of x, we can just drop that and leave us with x. This tells us x has to be less than or equal to 3, and now x is completely isolated. So let's get our number line up. Positives, negatives, here's 3. 3 numbers in each direction, 4, 5, 6, 2, 1, 0. We are starting at 3. This can be equal to 3, or less than 3. Less than 3 is to the left, and we're set. Really, these 3 problems represent just about as hard of a problem as you can get with your inequalities. They're just like what we did with equations. Normally, in a non-COVID year, this next part would encourage you to A, meet new people, and B, make sure that you and your classmates are doing things correctly. You're going to hunt down and try to find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different people. You'd switch your paper with them. You'd do the problem on their paper, they'd do the problem on yours. You'd switch back, and then you should be good, and you'd move off and find another partner. However, if this is a COVID year and we're trying to avoid being too close together, then you are just going to work through on your own. At the end, please call your teacher over so that he or she can check your answers, and we should be good to go. You'll need to pause me here because you're going to work these independently, asking your peers for help. If you do get stuck, you can hit play and check this out. If I make any mistakes, let me know. And then we're going to move on to some contextual or word problems to finish off class. Ready, set, good luck, and go. All right, you're back. Let's see how you did. Part D. Well, we've seen this one before. We actually saw something similar to this last class. This is -1 times x. So I'm going to rewrite the problem quickly. -1 times x is greater than 3. Okay. We are going to go ahead and divide both sides by that -1. And don't forget, when you multiply or divide by a negative, we switch the direction of the sign. 3 divided by 1 is 3, but a positive divided by a negative is a negative. You do have to draw your own number lines here, but I think you'll be all right. Negatives, positives. Here's -3, -4, -5, and -6. And we'll go 3 in this direction as well. -2, -1, and 0. We begin at 3, -3. We are strictly less than 3, or than -3, which means we go to the left. And we fill that in. Nothing bad at all. Next problem. 10 minus x is greater than -1. Well, 2 things. First, don't forget the one that's multiplying here. We should probably switch that order too. You don't have to, but it makes things, I think, a little easier. -1x, and then this 10 is positive, has to be greater than -1. Let's subtract 10 from each side. We always undo that addition and subtraction first. -1 times x is greater than -11. And then we, once again, undo the -1 that's multiplying times x. Because we are dividing by a negative, we do need to flip the sign. Negative divided by a negative is a positive, and anything divided by 1 is itself. Here's that friendly old number line again, centered at 11 this time. We have positives and negatives. 11, 12, 13, 14. And the other direction, 10, 9, 8. We begin at 11, strictly less than, and we have our friendly arrow. Part F. Negative x is greater than or equal to 3. We've seen this before. There's that invisible 1 that's out front. So negative 1 times x is greater than or equal to 3. Let's divide both sides by negative 1. Positive divided by a negative is a negative. Flip the sign. Number line, negative 3, negative 4, negative 5, negative 6, negative 2, negative 1, and 0. Here is negative 3. Let's shade that in because we have that equal to sign up above, and then we are going to the left. There we go. Next up, x divided by 4 is less than 2. All right, let's see how this one goes. X divided by 4 is less than 2. Because x is being divided by 4, we will multiply both sides by 4. Notice we're multiplying by a positive, so we do not switch the sign. This becomes x is less than 8. And we have our number line. Here's 8, 9, 10, 11, 7, 6, 5. And we're starting at 8, strictly less than, and we're good. Next up, h. This one is a little tricky, and we discussed it last class as well. We have this negative that's right here, and it could stay in the middle, could move to the top, could move to the bottom. I always like to place the negative on the number that's attached to x. So since 5 is dividing, I'm going to place the negative on the 5. Now that it's there, we're going to multiply both sides by negative 5. Always good to group, I guess. Times negative 5 over here. Multiplying by a negative 5 cancels out or forms a 1 with dividing by negative 5. Leaves x alone. We multiplied by a negative. We do need to flip the sign, and that gives us negative 10. All right. We have our negatives and our positives. Here's negative 10, negative 11, negative 12, negative 13. Always 3 in each direction. Gives your teacher a good idea about what you mean by different negatives and positives. Some of you always can surprise me and put your negatives on the wrong side, and as long as you show me, I'll give you the credit, but traditionally negative, more negative are to the left. Here's negative 10. No equal to sign. Looks something like this. All right. 5 minus 3x over 4. We did a problem similar to this last class as well. I'm going to rewrite this and do two things at once. First, it's a positive 5, so I'll put that at the end. And this is a negative, but notice that this 3/4 can be rewritten as 3/4 times x. 3x divided by 4 is the same thing as 3/4. Right? If you want to know why, I'll show you over here. Right? If I have, and we'll ignore the negative, if I have 3/4 times x, what that really means is 3/4 times x over 1. And we know we multiply fractions straight across, so that gives us 3x over 4. So if we ever have a fraction like this, we are welcome to rewrite it. You do not have to rewrite it. I just wanted to show you a different way than what we've seen before. Good practice to see math from different perspectives. So let's subtract 5 from each side. All right, negative 3/4 times x is greater than, I'm going to give myself some space here. 11 minus 5 is 6. And the reason I'm giving myself some space is because I know I'm going to get rid of this fraction, and I can do it all in one step. I'm actually going to move the negative to one of the numbers, doesn't matter which one, I'll put it on the 3. And to eliminate that fraction, we know that we can multiply by the reciprocal, 4 over negative 3. And so I'll want to do the same thing here. Notice I'm going to line up the 4 with the 6 and put the negative 3 down below so that I can see that this is 6 over 1. We know that reciprocals automatically cross-reduce each other, and it leaves us with x. We are multiplying by a negative here, so the sign needs to flip. And then we can multiply this straight across. 6 times 4 is 24 over negative 3. I'm going to run out of room with my number line, so I'll move to the right. 24 divided by negative 3 is negative 8. And I don't need to flip the sign again, because this negative here is the one that I flipped the sign for before. So x needs to be less than negative 8. Here's negative 8, 7, 6, 5. 9, 10, 11. There we go. And we need to go through and do this. And less than negative 8 is, of course, to the left. Okay, 2 more on this page. Ooh, fractions. Scary, scary. I especially like J because this is a pretty common problem, and I see a lot of students make mistakes here. And it makes sense because it doesn't really follow our SAD map. What we need to realize is that technically x minus 1, and I'm actually going to do the work over here, x minus 1 is all being divided by 3. And I think it's important to put those parentheses because we need to realize that you cannot undo the subtracting 1 because technically there are force fields or parentheses around the x minus 1. The only thing on the outside of the parentheses is what you're allowed to touch, and that's the divided by 3. So there are 2 options here, and I'm going to show you both ways. I think it's very important to see both ways. One option is you can remember that there's a 1 in front of x, and you can distribute the division to both of these. That was supposed to be a different color. There we go. We can distribute the division. So what this is going to give us is 1 divided by 3x minus 1 divided by 3, which is less than or equal to 2. And then from here you could solve. You could add 1/3 to both sides and then multiply by the reciprocal of 1/3. However, there is a nice little shortcut, and I'm going to show you the shortcut over here. Maybe I should say or, right? My other way that I can do this is if I have x minus 1 all divided by 3 is less than or equal to 2, if the divided by 3 is the only thing attached to the parentheses and there's nothing else on this side, a really common strategy is to actually go through and just multiply each side by 3. Because the multiplication won't reach the inside of the parentheses, it's going to get canceled out or undone by the division by 3 before it gets to the parentheses. Now I have nothing on this side besides x minus 1, and on the right side I have 6. Really, we don't need parentheses anymore. There's nothing else attached. You could distribute the 1 here if you wanted, but it doesn't really make a difference. We can just drop those parentheses. And now the solution isn't bad at all. Add 1 to each side, and you end up with x is less than or equal to 7. So I think this is a really nifty strategy here, and it's one that many students forget. So I think it's worth practicing. If you wanted to distribute and solve that way, you could. You might get some fractions. Another step from here is you could multiply both sides by 3 at this point to undo the fractions. We covered that in another lesson, but I would run out of room here. So let's get our number line, and then we can move on to our last one on this page. Here's 7, 8, 9, 10, and the other way, 6, 5, 4. We are beginning at 7. We're allowed to be equal to 7 this time, and then less than is again to the left. Guess I should have had some variety here. Oh well. All right, let's move on to problem K. Now, depending which version you have, and I've cleaned this up so all of you in the future years will have the right one, current years might not, I changed problems K and L. There were a few unexpected difficulties. So if your problem K looks like this, please go ahead and cross it off. And then I wrote the new one, so it's going to look something like this. It'll be 2x plus 4, this quantity divided by 3 plus 5 is greater than or equal to 1. I'm also going to tell you that part L might look different. There are 2 more problems. If your part L doesn't look like this, and I was able to update this one in time for my video, but it still might not be on your notes, please change part L to look like this problem. Okay, let's go ahead and jump back to this one, and let's solve. So, we have that similar situation to J, where 2x plus 4 is all being divided by 3. But this time we do not want to multiply by 3 at the beginning. And the reason is there is still a plus 5 at the end. So currently we have lots of things attached to x with a plus 5. We still need to undo the adding 5 first, and we'll do that by subtracting it from both sides. We want to isolate the fraction that has x. So this gives us 2x plus 4, still all being divided by 3, which is greater than or equal to negative 4. Now we can use the same shortcut as before. We can go through and multiply both sides by 3, like so. When we do that, they make a 1. This leaves us with 2x plus 4 is greater than or equal to negative 12. 2 steps remain. We need to subtract 12 from each side. Leaves us with 2x is greater than or equal to negative 16. And our very last step is we need to go through and divide by 2. Dividing each side by 2, notice that's a positive number, so we don't switch the sign. Tells us that x is greater than or equal to negative 8. From here, we just need to make our friendly old number line. We have negative 8. More negative is negative 9, negative 10, negative 11. More positive, negative 7, negative 6, negative 5. We are beginning at negative 8. We can be equal to negative 8. And greater than always means more positive. So we have this piece here. All right, 2 to go. L. 4 minus the quantity x minus 1 is greater than x minus 2 times the quantity negative x plus 1. We always try to tackle distributive property first, so let's take this invisible negative 1 and distribute. At the same time, let's take this negative 2 and distribute. Remember that to be in green. Computer took a second to catch up. So 4, this will become minus 1x. Negative times a negative is a positive. 1 times 1 is 1. Is greater than x. I'll put the 1 in front of the x. And this becomes negative times a negative is a positive 2x. Negative times a positive is a negative 2. Once we've distributed, we should combine some like terms. I see 4 and 1, and don't forget it cannot combine with anything on the right side. When we combine like terms, we pretend like the other side isn't there. 4 plus 1 gives us 5, and there's still a minus 1x on this side, is greater than, and on this side we have 1x plus 2 more x's, which I think gives us 3x's minus 2. From here, we want to add and subtract until all of our x's are on the same side. So I think we could probably go through and add 1x to each side. That'll keep our x's positive, which I prefer. You don't have to, and move them all to one side. 5 is greater than 4x minus 2. Okay. You can see that I'm going to run out of room, so I'm going to move over to this side. So we have 5 is greater than 4x minus 2. And to isolate x, since there's a 4 multiplying and a 2 subtracting, we should probably add 2 to each side. That gives me 7 is greater than 4 times x. So last but not least, we should probably divide both sides by 4. Second try. There we go. Make that stand out. This gives us 7/4 is greater than x, or if you switch the order, notice the point is pointing towards x, so x less than 7/4. Well, how do we do this on a number line? I'm just going to use the bottom of the box as my number line. 7/4, if you look for the decimal, I think it's going to give you 1.75. I'll write that over here. X is less than 1.75. You can find that on your calculator. You can think of how much is 7/4 and add up 25 cents. You'll get $1.75. So since that is not quite 2, I think I'm just going to go by ones here, and I'll just approximate it. It doesn't have to be perfect. So I'll kind of say this is 1, this is 2, 3, and 4. And then if I go the other way, we have 0 and negative 1. Okay, so 1.75 is in between here, and the sneaky way to do it is just add it in. Okay, it's somewhere between 1 and 2. We don't have to be perfect. That's the nice part with graphing. You don't have to be perfect. So I'm going to go through, and it says we're starting at 1.75. There's no equal to, so it's an open circle, and less than goes to the left. Great. Last problem, M. All right, M also asks us to isolate x. In the directions on the previous page, though, it tells us that we don't have to graph this, which is good because there's no numbers here. Graphing can get a little complicated. This is pretty darn similar to a couple problems we saw on the previous page with this fraction. So let's go through the steps. I think I'll work probably here and then skip over to the other side if necessary. So we have ax plus b. All of that divided by c is greater than d. First thing we'll need to do is multiply both sides by c. I think we should probably assume that c is a positive number. I bet they would have told us if it wasn't, because if it was a negative, we'd have to switch that sign. ax plus b is greater than, now you can write this as dc. I think typically they write these in alphabetical order, so they'd put the c first, but you don't have to. All right, I am going to run out of room. Well, no, I guess we're not graphing, so I'll do one more step here. I think we should probably subtract b from each side, because we're trying to isolate x, and there's two, air quotes, numbers, end quote, attached to x, b and a, but a is multiplying, b is adding. We undo addition and subtraction first. So I'm going to do that. That gives us a times x is greater than cd minus b. Now I have actually run out of room. ax is greater than cd minus b. To finish this off, I think we will need to go through and divide both sides by a. Don't forget to group so we can show all of that as being divided by a. And we have our answer. X is greater than cd minus b, all divided by a. Whew! Well, you guys just did a lot of really good symbol manipulation there. I am proud of you for getting through it. We have some quick word problems, contextual problems, problems with context to finish off, and that should be it for today. So let's begin. A local car dealership is trying to sell all of the cars that are on the lot. Currently, there are 525 cars on the lot, and the general manager estimates that they will consistently sell 50 cars per week. All right. Estimate how many weeks it will take for the number of cars on the lot to be less than 75. Well, this one you should just do on your own, right? 525 selling 50 cars per week. Just estimate. How long do you think it'll take for them to be less than 75, right? We're just going to guess. So, I don't know, maybe you think it's 10 weeks or something, or 12 weeks, or 9 weeks, or 8 weeks. So you get to put however many weeks that you would like here. Your choice. Part B. Write an inequality that can be used to find the number of full weeks W it will take for the number of cars to be less than 75. Since W is the number of full or complete weeks, W equals 1 means at the end of week 1. Oof. Okay, so let's take a look here. So I think we can kind of break this down. And the first part is we know we want the number of cars to be less than, come on highlighter, to be less than 75. I bet I could write that as an inequality, less than 75. Ha! I got part of it. Well, the rest of it, though, I think we have to take into account the 525 and the 50 cars per week. Well, 525 is pretty easy because that's a number, and that's what we start with. We start with 525. And what's happening to the 525? Well, we are losing some number of cars. How many cars? Well, you could say 50, but we don't just lose 50. After week 1, we lose 50 cars. After week 2, we lose another 50. We'll have lost 100, and then another, and then another. They said to use W for full weeks. If it's 50 cars per week, couldn't we do 50 times W? Think about it. If W was 1, then that would mean 525 minus 1 of those 50s. If W was 2, it would be 525 minus 2 of those 50s, and so on and so forth. And I think from here, we have an inequality that we can use to determine how many weeks it will take for the number of cars to be less than 75. In fact, we should probably work with that inequality and solve it. So I'm going to take the most space I have, which seems to be over here. We'll just use 2 columns just in case. 525 minus 50 times W is less than 75. And we'll zoom in here. I am going to rewrite this really quickly. I'm going to put the negative 50W first and the positive 525 second. I think that'll make our lives easier. So now hopefully we can see our first step is we need to undo the 525 from each side. You may need your calculator on this problem, not a bad thing. Use that Desmos graphic or that Desmos scientific calculator or whatever floats your boat. It's not a big deal. You can do whatever calculator, phone, regular calculator, anything like that, but make sure you have it up and ready, and hopefully I've stalled enough for you to get your calculator. This will give us negative 50W is less than negative 450, and I have run out of room. So negative 50W is less than negative 450. And last but not least, I think we do need to divide both sides by the negative 50 that is attached. There we go. And we get weeks. And hopefully you can see this, right? If you chop off the zeros, really we're just dealing with 45 divided by 5, which I think is 9. And then it has a strictly less than. However, we divided by a negative, so I think we have to flip it. W is greater than 9. Let's go ahead and graph this. Okay, we're starting at 9. I always like to do 3 numbers in each direction, 8, 7, 6. And starting at 9 tells us W has to be greater than 9, no equal, so we don't fill it in. Greater than 9 is to the right. Part D, interpret the solution in the context of the problem. Well, W greater than 9, W stood for, let's see, the number of full weeks. Okay, so let's see, and this says weeks greater than 9, so don't think we can use 9. We need to say any week after 9 weeks will be when the lot has fewer than 75 cars. I think 9 is when they have exactly 75. So the next week, the 10th week, 75 minus 50, they'd only have 25 cars. And then actually the 11th week would be weird. I think the 11th week they would start to have negative cars. Maybe people would owe them cars at that point. But yeah, what we did here is we were able to solve and find how many weeks made it exactly 75, which is 9. But then they said we wanted to know when the number of cars was less than 75. And so we needed to say anything more than 9, like 10, 11, 12. All right, 2 to go. For problems 2 and 3, write an inequality, then solve and graph and interpret the solution. There's not a lot of work, or not a lot of room for work here, but we'll see what we can do. The cost of renting a car is $25 per day plus a one-time fee of $75.50 for insurance. How many days can the car be rented if the total cost is to be no more than $525? All right, let's break this down. $25 per day to me means we're doing $25 times D, where D is the number of days. There's also a one-time fee of $75.50. So if you're only paying this once, I think you're just going to add on $75.50 to however much you're being charged after some number of days. And then how many days can the car be rented if the total cost is to be no more than $525? Well, no more than $525 actually means $525 is the limit. That means less than or equal to $525. So let's put all this together. We know we have 25D plus $75.50 will be the total amount you pay. And then we want to know, when is this total amount going to be less than or equal to $525? Well, I think we can probably isolate here. We know to undo addition, we use subtraction. And again, you might want your calculator here. You can do this by hand if you'd like, but hey, I mean, we all pretty much have calculators with us these days, so we might as well take advantage of them. I'm doing it on mine, just off screen. 525 minus 75.5 is $449.50. And then I think we should finish isolating by dividing off the 25 that's still attached to D. And when you do that, you're going to get, let's see if I can get this right, D, this makes 1, is less than or equal to, we don't need to flip the sign, everything's positive here, is less than or equal to 17.98. All right. They did ask us to graph this as well, so I'm going to go ahead and just use this piece right here. Always nice when you have a straight line. 17.98, let's just call this 18, positive, negative. So this is 17, 16, 15, and 19, 20, 21. 17.98 is right here. And I'm just going to maybe write this sideways just because it doesn't fit in too well. There we go. D has to be less than or equal to that, so we're starting there. It can be equal. And then we go less, and we have this piece. Excellent. Okay, well, how many days can the car be rented if the total cost is to be no more than $525? Well, they wanted us to interpret what we got here. This D stands for days, I think. It tells us the days have to be less than or equal to 17.98 days. If you rent it for exactly 17.98 days, then it's exactly $525. So I think that's basically telling us we can't rent it for 18 days, right, or even 17.99 days. So I'm not sure how you want to interpret this. I would say probably on the safe side, rent the car for 17 days or fewer. We always use fewer with countable nouns, right? With 17 days or fewer, 2O less than or equal to $525. Now, technically, you could go a little over 17 days to exactly equal that, but oof, car companies, I don't know. I would play it on the safe side and say no more than 17 days. All right, last one. Mrs. Smith decides to buy 3 sweaters and a pair of jeans. She has $120 in her wallet. The price of jeans is $35. We'll keep that in the green. What is the highest possible price of a sweater if each sweater is the same price? Interesting. So let's see what we can do here. Pair of jeans is $35. So we know that she's going to buy $35 first. Didn't like that. $35. And then she's going to add on 3 sweaters. However, I don't know how much each sweater is. But since they're the same price, we can just do 3 times whatever that price of the sweater is. I'll do P. And the reason I'm choosing P and not S is because my S's look like 5s a lot of the time, right? If I do an S versus a 5. So I tend to move away from that variable. So $35 for the jeans plus 3 times whatever the price is of the sweaters. And if she has $120 in her wallet, she doesn't have to spend that full $120. But she can spend up to it. So maybe I would say less than or equal to $120. All right, let's go ahead and isolate and see what we can get. We know we need to subtract the 35 from each side. Okay, so we're doing okay here. This gives us 3 times P is less than or equal to, what's this one going to be? I think that's 85. Almost said 185. Whoops. 5 and 5 is 0. 11 carry the 1 is 12. Excellent. And then we need to divide both sides by 3. And I think 3 does not go nicely into 85. 8 plus 5 is 13. 3 doesn't go nicely into 13. So we can keep this as 85 thirds. But since we're talking about prices, we might want to go through and actually find the answer in decimals here. And I think that we can get in 28.3, or money 33 if you'd like. All right, let's go ahead and graph this quickly. 28.3, so I'm going to have 29 and 28 because 28.3 is in between those. 27, 26, and we have 30 and 31. All right, so let's see, 28.3 is somewhere in here. Again, I'll write that sideways just so it doesn't get lost. Our price can be equal to that, so we need to fill it in, but it can also be less than. Very nice. So let's go ahead and interpret our answer here. What's the highest possible price of a sweater? So we could say something like this. The highest priced sweater Mrs. Smith can afford is $28.33 each. Whew! All right. Well, we've gotten through all of this now. To finish off class today, your teacher is going to give you a quick survey. And realistically, I'm going to give my students a quick survey. Your teacher might not do that. So the survey is just going to be about how this first couple weeks of algebra has been going. Have you established a homework routine? Do you need more help? How can I reach out and help you a little bit better? Normally on your paper, the link is going to be right here. I didn't include the link though because I don't need other people doing my survey. Now, if you do have extra time, if you finish off the survey, I do have 2 extra credit riddles on here. Both of these are from Pizzazz Algebra, Algebra with Pizzazz. I retyped them, though, because it makes me happy. So you have 2 riddles, one on this page and one on the next page, and it's totally up to you which one you'd like to do once you finish the survey. If you want to do one or both for extra credit, not a bad thing at all. Please just use a separate piece of paper. So thank you as always for hanging out with me. I hope this made a decent amount of sense. As always, if you have any improvements or suggestions, or if I made any mistakes, please let me know, and I will do my best to update them. Have a wonderful day.